Okay, so we've interpreted the Raman spectrum of methane successfully. Next, we're going to tackle the problem of the infrared spectrum. And so here are the results from an IR spectrum of methane. You can see there's 4 peaks. They're at 30, 40, 28, 23, 1720, and 1300. And so at first you might say, well, this kind of makes sense because just like the Raman spectra, there's 4 peaks. So those are the 4 modes, right? Well, that would be completely wrong line of thinking, because remember from our selection rules that only 2 of the 4 normal modes were IR active, okay? And those were the T2 modes, the 2 T2 modes. There's 2 of them. And so the other 2 peaks that are in this spectrum must be coming from something else. And infrared spectroscopy is complicated as compared to Raman spectroscopy because you have overtones and combinations, as we talked about previously. And we'll work through the selection rules for overtones and combinations. And we were able to calculate that both of the T2 overtones are allowed by infrared spectroscopy selection rules. So remember, there's going to be 2 overtones here because there's 2 T2 normal modes from which to derive those overtones. So, you know, one of them could be the T2 mode that's doubled in energy, and then the other one would be the other energy, different energy of the T2 mode, different T2 modes, like one's a bend, one is a stretch. For this case, we know, we figured that out. So it could be double the energy of the bend. Remember, overtones are always double the energy about. And the other one could be double energy of the stretch, okay? And then we had a whole mess of different combinations that were also allowed by our spectroscopy rules. Basically, T2 plus or minus anything, including T2 plus or minus the other T2, okay? So what we want to do here is use the results from Raman spectrum. Always want to start out with the Raman spectrum in this sort of interpretations, and use that as a starting point. So we made some assignments here, right? There's some uncertainty on the bottom about which one was the T2 bend and which one's the E bend, but we narrowed it down to 2. But the symmetric stretch A1 and the T2 stretches we got down. So what I've put here is, okay, T2 fundamental. We're gonna try to figure out now what peaks are present, okay? So T2 fundamental, that was our T2 fundamental from the Raman spectrum, 30-20. So we know the energy, if you're just doing that type of asymmetric stretch, that type of T2 stretch, it's going to be at 30-20 wave numbers, okay? Now the other T2 is IR allowed, but we don't know from the Raman spectrum if it is properly assigned to 1526 or to 1306. So this is where things are really going to get interesting. Now, overtones, we can start searching for overtones. Overtones are just going to be double energy. So 60-40, well, nothing was even close to 60-40. And then doubling both of these, okay, giving us 1526 doubles 3052 and 1306 doubles 2612. And then we can start adding in the A1s. So the A1 we know from Raman was what, 2914. So we're just going to add 2914 to 3020. That gives us our predicted peak position for the T2 plus A1 combination. We went over that, combinations can be additive or subtractive. So we can also do 1320 minus 2914, right? That would get us a pretty low number, 106. Probably not going to be close to anything. Both of these are, really high and low numbers off of the typical scale for infrared spectroscopy. Now plussing with E. Okay, well, we don't know what E is, right? We said that it's either 1526 or 1306, and one of those is T2 as well. So we can add 1526 to 1320 to get one possibility, or add 1306 to get the other possibility, 4326. Same thing with subtracting. We're gonna subtract 1526 or subtract 1306 from 3020. And then the T2s. Well, what is the T2? Again, we don't know. It's either 1526 or 1306. So we'll add a 3020 plus both of those to get two combinations, and then we'll subtract 1526 or 1306 from 3020 to get two combinations. And then we're going to do the same logic for walking through the T2 bend. Again, the T2 bend, we don't know what it is. It's 1526 or 1306, but we're hoping to kind of work through this puzzle to figure it out, right? So two overtones that could be possible are just double these values, plus A1. A1, we know, again, is 2914. So we're going to do 1526 plus 2914. That gets us one possibility. And then 1306 plus 2914. And then subtracting. And so if you take any of these numbers and you subtract 2914, you're going to get a negative number. You can't have a negative energy, so those are out. I just put less than 0 there. Plus E. Okay, plus E. Well, that's going to be, we don't know what E is, but it's the opposing one. If T2 is 1526, E is going to be 1306. So that gets you 1526 plus 1306. That gets you 2832. If T2 is 1306, then E is 1526. So that gets you 1306 plus 1526, which is the same thing, 2832. So that one ends up being the same. Then subtracting them, well, if T2 was 1526, we could subtract from 1306 to get 220. If it was the other way around, that would be 1306 minus 1526. That's a negative number, so we don't have to worry about that one. That's not valid. Adding T2s. T2, well, T2, the other T2, we're doing a combination between the T2 bend and the T2 stretch. So it's going to be 1526 plus 1320 or 1306 plus 1320. Those are shown here. And then if you try to subtract 1320 from any of these numbers, that's going to get you a negative number, so you get less than 0. So now at this point, we're going to look at the IR spectrum, 3040, 2823, 1720, and 1300. And for IR spectrum, you're going to just try to get the numbers that are close enough. At the end of this chapter's lecture, I'll explain to you why the numbers aren't exactly as predicted, okay? But we're just going to figure out which ones are close, okay? And the closest ones are the ones circled here, okay? And so you have 3020 fundamental, 3040 showed up. So that tells us kind of right away, and the 1306 was close. So that tells us that actually 1306 was the T2 bend, and the E bend must be 1526. And then we got the energy of the T2. We already knew that from Raman spectroscopy was 3020. And now you go through here and you can kind of, select which ones are the closest. We're looking for something close to 2823. The closest here is 2832. So we're going to say that 2823 is due to a T2 plus an E combination, okay? And then the closest one for 1720 was 1714. That's going to be a T2 minus a T2 combination. Now, you might be looking at this first row, and this is a question that's come up in previous years. Why didn't you choose this 1714? There's two 1714s here. Why didn't you choose this 1714? Well, we have to think about what those 1714s represent, right? That 1714 there, this one, represents when E is 1306, right? And E is not 1306, that's T2. So this value is no longer valid, right? That's not an accurate position for the T2 minus E anymore. If it did show up in the spectrum, it would be at 1494, because we know now that the T2 is 1306. So it should be 3020 minus 1526 for E, which is 1494, okay? So again, we were just doing hypotheticals. What is the T2? I don't know. Could be one or the other. But now we do know, after we matched and looked at the spectrum. And so we know that the E, therefore, the E is 1526, and so 3020 minus 1526 is 1494, not 1714. So this one is correct, because this 1714, where did it come from? It came from T2, which is 3020 minus 1306. It's a T2 minus the T2 stretch. All right, so let's stop there, and then we'll go over one last concept called Fermi mixing, which will explain why these values don't correctly match.